Next up, we're going to look at an idea that you've probably seen multiple times before, honestly, probably every year since sixth grade, the ideas of solids, liquids, and gases. So very quickly, the definition of each. A solid is a phase of matter that has a definite shape and a definite volume. A liquid has a definite volume but no definite shape, and a gas does not have a definite shape or a definite volume. So let's talk about what that means real quick, and then more importantly, we're going to explain why that is. We're going to look at a combination of temperature, forces between particles, and the kinetic molecular theory to explain why they behave the way they do. So first, a solid has a definite shape. That means that if left alone, a solid, or an object in the solid phase, will keep its shape. Its shape won't spontaneously change. Same thing with the volume. To have a definite volume means that the volume won't change on its own. Now the volume can change if you were to add more atoms to the substance, or if you were to break it in half, whatever. However, if you just leave it alone, the shape won't change and the volume won't change. For a liquid, if it's left to its own devices, the volume won't change, but the shape will change. It'll take the shape of its container. And with a gas, left to its own devices, it will take the shape and volume of whatever container you put it in. All right, now back to why this is, because that is the most important thing about this whole idea. And what you have to understand is, first, anything can take solid, liquid, or gas form. If it's made out of matter, it can be in any one of these three phases. So pick a substance, any substance. If we want to talk about silver, I can have solid silver, which we're all pretty familiar with. If I heat that up, I can then have liquid silver or molten silver. And if I keep heating that to really, really ridiculous temperatures, I can get silver as a gas. So any substance can take any of these three phases. And really, for an individual substance, the difference between these three phases is the speed of the particles of that substance. In a solid, the particles are moving much more slowly. In a liquid, they're moving a little bit more quickly, and in a gas, they're moving a lot more quickly. Now remember, temperature is our measure of this, and if we take for neon and we look at the temperature of the solid, and then the temperature of a liquid, and then the temperature of a gas, we see that as you go through the phases going from solid to gas, that the temperature, the average kinetic energy of the molecules, increases, or atoms in this case, I should say. So now let's talk about what this has to do with definite volumes and shapes and all that jazz. So we understand that temperature is a measure of the speed. We also have to understand that there are very small forces between these particles of matter. You can almost think of it as each one of these little atoms is covered in a layer of Velcro, and so if you put them together, they'll actually stick, provided, of course, there's nothing forcing them apart. And the thing that forces them apart is how quickly they're moving. So with a solid, the particles are moving relatively slowly. That means that that Velcro, if you will, the forces between the molecules, can actually hold them right together. I keep saying molecules, but for neon, it's atoms. You'll learn the difference later. So between these neon atoms, these forces between the atoms are holding them together. If I look at this particular atom right here, it's stuck to its neighbors and it can't move. It can't move from that spot. It's stuck to those particular ones, which means this has a definite shape. The shape of this cannot change because the atoms are locked in place. For that same reason, the volume of this never changes because those atoms can't move anywhere. All they can do is vibrate back and forth. And as you heat up a solid, all that's happening is those are vibrating more and more quickly. Now, if I heat this up to the point where it gets to be a liquid, what we see is that these are now moving fast enough that they can tear away from their neighbor. Imagine just like slowly pulling Velcro apart. These will move from neighbor to neighbor. If you watch these along the top, what you'll see is they can kind of bounce along the top and they get stuck to different neighbors at different times. This is what causes a liquid to flow. The atoms can move past each other, but they're not moving fast enough to break away from those forces completely. So they remain stuck to each other, but they can move around and stick to different ones. This is why a liquid doesn't have a definite shape, because those atoms can move around, But unless they have enough energy to get into the gas phase, they are completely stuck on there, and so a liquid has a definite volume. Once we get to the gas phase, these particles are now moving so quickly that those forces between them practically don't exist. Imagine taking two tennis balls covered in Velcro and shooting them at each other at 100 miles per hour. The idea that they would stick together as opposed to just hit and tear past each other is slightly ridiculous. And that's what's happening here. They're moving so quickly that the forces can't hold them together. And so they bounce off each other and they go in different directions. This means there's nothing holding the atoms together, so they have no shape, and they can't be held together to have a particular volume, so they spread out amongst wherever they are. So again, two things we're looking at: shape and volume, how much space it takes up. And as these things speed up and break away from the forces between them, the first thing to go is shape, and then the next thing to go is volume. So with a liquid, it's no longer sticky enough to hold a shape, and with gas, it's no longer sticky enough to hold a volume anymore.